In this video, we'll learn about lazy materialization, which was introduced in ClickHouse 25.4. Lazy materialization means that we defer reading columns for as long as possible, and it works well for top-end queries, especially ones where we're maybe returning some string columns in the final result. Let's launch ClickHouse and see how it works. So I've got a table called Amazon Reviews, so let's have a look at that. And you can see it's got some numeric columns like star rating, helpful votes, total votes, but then also some string columns like product title, review headline, and review body. Let's have a look how much data we're working with, and so you can see we've got 150 million rows, and this is running on my laptop, a MacBook Pro from 2023. Now here is an example of a type of query that we might run on this dataset. So imagine I'm trying to find an ebook to read, I want it to be a verified purchase, and I want it to have a good star rating, and then we're going to order by the helpful votes. And at the moment, we're just going to return the helpful votes and the star rating. And we've got the lazy materialization optimization turned off. So this is effectively how things were in 24.3 and earlier. And you can see it comes back 0.2 seconds. We've got our helpful votes and we've got our star ratings. If we turn the lazy optimization on and run the query again, you can see it takes about the same amount of time. The only thing that's been optimized is that we haven't had to read all of the star rating column values into memory. It's only loaded the values for the top 3 rows ordered by helpful votes. Keep in mind that to properly test this feature, we should clear the OS level file system cache between each run, but that's hard to do on the Mac, so treat these as approximate comparisons. To see why there wasn't much improvement with the optimization turned on, let's have a look at the size of data in each column. And if we highlight helpful votes and star rating, you can see that those are 72 meg and 41 meg compressed each. That's not actually very big data, and that, in the terms of the total query time, is fairly inconsequential. Now what we really want to do is probably return some of those string values, so review body, product title, and review headline. And if you look at those are much bigger, so 21 gig, 3 gig, and 1.5 gig in size. So we're going to include those in our query, but first here's a function that's going to just truncate it for visualization purposes so it doesn't bombard the whole screen. And then we're going to have our new query here. So we're going to have same query as before, same filters, but the select is going to have helpful votes, and then we're going to have the product title, the review headline, and the review body. And we'll start with the optimization turned off. So we'll run that. You notice it takes a little bit longer. Maybe we'll speed it up for the video. And you can see it takes just over 2 seconds to tell us what the answer. Now, if we turn on the optimization this time, it's almost immediate in its response, and it's 0.2 seconds to do the same thing. And this time it hasn't loaded 55 million strings into memory, it's just done those last 3 at the end. Now, several ClickHouse optimizations rely on you filtering the data in some way for them to be effective. Lazy materialization isn't one of those. So if we have a look at this query here, we've taken out all of those where clauses. And if we run the query with lazy materialization off, we're going to have to speed this up because it takes just under 10 seconds and it's processing every single record in the whole table to give us the result. And it takes 9.8 seconds. If we turn the setting on and run the query, it's now 0.1 seconds because again, it hasn't had to load all those strings into memory to give us the query result. So this is only one of the recent optimizations in ClickHouse. Check out this video up here about the query condition cache to see another one.